Hello everyone, my name is Bhiman. Today I will be presenting our work, but before that, I would like to apologize on behalf of both of us for not attending the event in person. That being said, I present Multimodal Understanding of Memes with Fair Explanations. As evident from the title, our goal is to examine meme explanations generated by vision language models through the lens of fairness. Let's understand with an example. Given a meme, when a vision language model is asked what the meme conveys, it generates an explanation based on its understanding of the meme poster. You can observe here that group of people are identified as participating in a race instead of people running from fear of death from the rocket. Additionally, the word democracy in the meme has swayed the model thinking that rocket symbolizes unity instead of death. This example clearly demonstrates bias in the generated explanation, and our goal is to identify the reason behind it. But why memes? Memes are unique combination of image and text, plus they are widely used metaphorically. All these characteristics and associated metadata make memes challenging to understand than regular images. So, we aim to examine the fairness of generated explanations when explicitly presented this metadata. To achieve our goal, we collected various publicly available meme datasets. However, they lack certain input required for our experimentation as shown with gray gaps. To fill these gaps, we used OCR to extract the meme text and vision language models to generate their captions, later used to generate the explanations as well. This new enriched and unified data set of memes is our first major contribution. We used Lava 1.5 and MiniGPT-4 vision language models with following categories of prompts where raw contains only the meme poster, and as we proceed, we explicitly add more information like OCR, caption, and metadata. Moving to evaluation, we begin automatic evaluation using off-the-shelf models like toxicity and profanity and APIs like Google's Perspective API. The table shows the result for Perspective API. It can be observed that very few explanations are classified as toxic, and when OCR and captions are added, the toxicity is increased. We also see an increase in toxicity when moving from Lava 1.5 to Mini GPT-4. But are these metrics telling the same story? Interestingly, no. When we examined the correlation between these metrics, we observed very less correlation among them, evident from the darker shade of the first two rows or columns. This finding is our second major contribution and raises concern about their reliability. To find the reason for bias, we performed manual evaluation. Looking into the previous example, we found out that because of common visual feature of people participating in race has led to such misattribution. Additionally, since the word democracy is generally used with positive sentiment, here the deadly rocket is seen in positive sense. We found out four broad reasons of bias towards common visual feature, towards group entity or gender, towards image then text, and towards sentiment associated with words. The table shows their spread across the dataset and prompts. These findings become our third major contribution. During our manual evaluation, we observed that vision language model may struggle to understand the text in the memes and generate biased explanations. However, by providing the correct text through OCR, we can mitigate the bias. As shown in this example, where earlier the explanation says US democracy is flawed, which is not what the meme poster is trying to convey. However, in the later, with proper text provided, it got the explanation correct. Another finding is that if the caption generated is biased, like here, the model thinks that the human is holding a hammer. This biased caption later influences the explanation to be biased. These findings add to our contributions and should be utilized in mitigating bias. Finally, I would like to conclude that with an aim to examine the fairness in generated memes explanations, we found out that certain vision language models carry biases Through our proposed unified dataset, we performed both automatic and manual evaluation and found different origins of bias, encouraging effort towards development of fair and safe AI. Thank you everyone. Feel free to contact us for any discussions. Thank again.